All right, so if you can see this, I think you have it on your note package. Should be okay. So go ahead and turn to 8.3, trigonometric ratios. And I'm going to give you the definitions for the three trigonometric ratios that you need to memorize. Okay. The first one is sine of an angle A. So this is just like our geometer sketchpad picture. Here's angle A. I switched up B and C on you, it looks like. B was our right angle and C was up here. So here's angle A. So if I am standing at angle A, then the sine of A is the ratio of the length of the side opposite A, this blue one, divided by the length of the hypotenuse, the green one, which we're going to call C. The cosine of A is the ratio of the length of the side adjacent to A divided by the hypotenuse. Now, did you catch the difference between the hypotenuse and the adjacent? Each right triangle only has one adjacent. Okay, because the hypotenuse kind of takes precedence or is king over the adjacent. So although this green line segment here is adjacent to angle A, it's the hypotenuse first. Okay, so the hypotenuse is not also the adjacent. So we only have one adjacent, one hypotenuse, and one opposite side in each right triangle. Okay. Then the tangent of an angle, tangent of A, is equal to the side opposite A divided by the side adjacent A, or A over B. So we've put together a little acronym to help you remember it. It's listed as SOHCAHTOA. Somebody want to read the little story up at the top? Wants to read it here. Dramatic reading of the story. It's behind the legend of SOHCAHTOA. So you want to read it for us?
I'll read it.
Okay, go for it.
A long time ago, in the lower Mississippi Valley, there was a very special Native American. Whenever a tree needed to be cut, all the council leaders consulted her for advice, for they did not want to cut down a tree that would crush their home. Each time, using her complex understanding of the dynamics of the universe, she was able to correctly identify which trees would be suitable.
So the S in SO stands for sine. The O stands for opposite. The H stands for hypotenuse. I just get abbreviated here. And so the sine of an angle is always the ratio of the length of the opposite side over the length of the hypotenuse. What do you think this is saying? What does the C stand for? It's short for cosine. And cosine is spelled C-O-S-I-N-E. Sine is S-I-N-E. And then tan is short for tangent. And you'll see these three buttons on your calculator. So cosine is always the length of the side adjacent to the angle over the length of the hypotenuse. And it does make a difference on the order. Notice the O comes before H. So look up here in the ratio. The side opposite of A is above the hypotenuse. So the order matters on this little acronym. Okay. And the last one is tangent, is defined to be the opposite, or length of the opposite side from angle A over the length of the adjacent side from angle A. So that's a little acronym to help you remember these three trig ratios. Okay. Let's do a little practice and set these up. It says find the sine, cosine, and tangent of the angle. Leave as a fraction. So first of all, I have a right triangle. I'm given the adjacent side. Well, the adjacent side for angle S is 12. The hypotenuse is 13. Using Pythagorean triples, can you tell me the other length? No.
I have a question.
Yes.
Why is sine still looking instead of
GN, because it's not the same thing as the sine SIGN like the stop sign. it's referring to the sine ratio. So SIN is abbreviation for SINE, which is referring to a ratio of two sides of the right triangle. So completely different thing. So you guys using the Pythagorean triples, tell me what this missing side length is. It is 5, yes, because 5 always goes with 12 and 13. 5, 12, 13, right triangle. So once you know all three sides, and you may have to find a side using the Pythagorean theorem, Pythagorean triples, or perhaps special right triangles. But once you have all three sides, then you can set up the ratios as fractions. So if you can just remember, the tangent of an angle A is just a ratio of two sides of a fraction. Same thing with sine or cosine. It's just a ratio of two sides. That's it. So when I ask for the sine of angle S, sine of S, it's going to be equal to, here I am standing at S. The sine of an angle S is defined to be the ratio of the opposite over the hypotenuse. So sine of S is 5, opposite, over hypotenuse, 13. And that's it. You're setting up an equation. What about cosine of S? Here I am standing at S. Cosine, according to our acronym, is defined to be adjacent A over hypotenuse H. So what is the adjacent angle S? It's the 12 over hypotenuse 13, and I've got it. And one more to do here. Tangent of S. Can you tell me what the ratio of the sides corresponding to the tangent of angle S would be? 5 over 12. Yeah, opposite over adjacent. So 5 over 12. So there is a specific angle S that will give me those particular ratios. I haven't shown you how to find that angle S yet, but I will. Let's do angle R. So now if I change my perspective, I'm standing at angle R. What would cosine, or let's start with sine, what would sine of R be? If I'm at R, now what is my opposite side? It's the 12, and my hypotenuse is still 13. And then I have cosine of R. So cosine of R is going to be what over what? Yes, it's the adjacent to R, which is 5 over the hypotenuse. And then finally, tangent of R is equal to opposite 12 over adjacent 5. And those are my three trig ratios from the two different angles. Now, how come we are not asking for sine, cosine, or tangent of t? We usually get this question sometime. We're typically asking for sine, cosine, or tangent of the acute angle. Do you have any ideas, Mitchell? Yeah. That's part of it. That's the right angle. We typically don't ask for sine, cosine, or tangent of the right angle. You know, if we were to say, okay, what's the sine of t? Well, sine of t would be the ratio of opposite over hypotenuse, right? Well, if I'm standing at t, what is the opposite? 13. What is the hypotenuse? Yeah, which is 1. That's correct. But you know, we don't ask for the angle or the sine, cosine, or tangent of the right angle. We'll be asking for the other two acute angles. I'll show you in the special right triangle. It's kind of how this relates to special right triangles too a little bit later. So any questions on this? All right, this is find, here it is, find the trig ratios of the angles for a 45-degree angle. Don't use a calculator. Well, let's draw a picture of my triangle for the 45-degree angle. First of all, it needs to be a right triangle. if this is 45, then this is also 45, right? So if I have one 45-degree angle, the other has to be 45. If I call this x, what is this over here? X. And what is this? It is. But what is it in terms of x? This is a special right triangle. What do we do with the leg to get to the hypotenuse? X squared 2. Okay. So if I want to find the sine, now I'm giving you a specific angle. I'm not calling it by a letter. I'm saying it's a 45-degree angle. So sine of 45 degrees. It could be either one of these 45-degree angles, and I'm not going to ask you for sine of the 90. So sine of the 45 is going to be defined as opposite x over hypotenuse, x root 2. Can that be simplified? Yes, it can be simplified. First simplification would be x's cancel, leaving me with 1 over root 2. That's not an acceptable answer in simplified radical form. So what do I do next? Multiply by root 2 over root 2, which leaves me with root 2 over 2. Okay. 2 over 2. So in a 45-90, the sine ratio of that 45-degree angle is always going to be root 2 over 2. This is something you'll use in trigonometry. Okay? All the multiples of 45-degree angles are 45, 90, 135. You got another 45 here at 180. When you study trigonometry, you'll be expected to memorize all those multiples of 45. What about the cosine of 45? Well, the cosine of 45, pick either one. If I'm right here, it's adjacent over hypotenuse, right? So x over x root 2. Well, what's that going to simplify to? Same thing again, right? Same process, same value, 2 over 2. Okay, I've got one more here. What about tangent of 45 degrees? Let's put it right here. What's tangent going to be? X over x, yeah. Opposite over adjacent. What does that simplify to? Yeah, 1. So tangent 45 degrees is 1, which we looked at the other day. The two legs of the 45-45 right triangle are always going to be in a 1-to-1 ratio. Okay, they're always the same. So those are the sine, cosine, and tangent ratios for 45 degrees. The other special right triangle is one where there's a 30-degree angle in it. So it would look like this. Let's draw a picture here. We know it has a 90. We're studying only right triangles right now. Okay, so it has a 90. If I put a 30 in here, what's the other angle? 60. So it's a special right triangle as well. You tell me the ratios on it. If I call this x, what is it? This one is x root 3. What's this one up here? 2x. Good. So now we're going to do the same thing again. Okay, so first of all, sine of 30 degrees. What's the sine of 30 degrees? Opposite x, yep, over 2x, yeah, hypotenuse, OH from our acronym, right? So is S sine is opposite over hypotenuse. So I just copy those down, then simplify it. What does this simplify to? This 2. It's 1 over 2. What about cosine? 45. Cosine of 30 degrees. That's going to be what over what? x root 3 over 2x. And what does that simplify to? Root 3 over 2. And then we have tangent of 30 degrees is equal to the opposite, which is x, over the adjacent x root 3. What does that simplify to? Yeah, it's 1 over root 3. X's cancel out here and here. And then I've got to take the 1 over root 3 and multiply it by root 3 over root 3, which ends up being root 3 over 3. Yeah. So those are the trig ratios of the two special right triangles. So the question is, how do you use the trig ratios to find the missing side length of a right triangle like this one? First of all, I should ask you, why can't I use the Pythagorean theorem on this? Yeah, I don't have two sides, I only have one. Why can't I use special right triangles on it? It's not, that's right, it's not a 30, a 60, or a 45, right? So those two are out. Section 1 and Section 2 are out. We need another method. So and this is a pretty common method. It's not hard to have a device that will measure angles. I actually have a rudimentary one that I'll show you next week. Hope it's not raining on Tuesday, but try to show you next week. We'll go outside and you can actually measure an angle. It's a little device. All it's made up of is mine is a straw, a little what's called a clinometer, and then some kind of weight on it to give you an angle measurement. It's pretty rudimentary, but it gives you an approximation of the angle measurement. And then if you measure one of the lengths of the triangle, you can find the other two using these trig ratios. I mean, that's what they use to do indirectly measure, for example, the height of one of the trees out here or something like that. So if I know this angle is 28 degrees, the 14 is the opposite side, and D is the hypotenuse, which of the three trig ratios would it involve opposite and hypotenuse? Sine, yeah, sine, S-O-H. If you look, I mean, go back to this previous page here. So is sine is always the opposite and the hypotenuse. I want to find the hypotenuse, I'm given the opposite, okay? And this will be the case on each one of these. You will be given one of the three ratios, and you'll be asked to find another one. Okay, it'll be denoted with a letter. And depending on which angle I'm at, we'll decide, which trig ratio we need to use to solve it. So what I'm going to do is set up my trig ratio as sine of 28 degrees equals what over what? 14 over D. Now, I'm going to do something with my left-hand side of this equation. I'm going to put it over 1. I'm trying to connect this to last chapter. What do we call this equation? It's a proportion, yes. It is a proportion. As a matter of fact, sine of 28 degrees is simply a number. Okay? It is an irrational number, but it's just a number. If you take out your calculators, if you don't have one, go ahead and grab one here. Pull out your calculators. I'm going to show you how to get the sine of 28 degrees. So what would the setup for be? Here I am standing at the 18-degree angle. I want to solve for x. What would x be? The adjacent, the opposite, or the hypotenuse? Adjacent. So I need something that involves a adjacent, and what would 42 be? Hypotenuse. So which one of those three involves a and h? Cosine. So what would my setup be? Cosine of 18 degrees equals what over what? What's CAH? C-A-H. The A comes before the H, so adjacent goes on top, hypotenuse on bottom. Now, cross multiply to solve it, right? So this is x equals 42 times cosine of 18 degrees. As a matter of fact, these two represent the two types of equations you'll have. Either the letter is going to be on the bottom, So therefore, you'll have to divide by the trig ratio, or the letter will be on the top, in which case you will multiply by the trig ratio. Okay, that's it. Grab our calculators. It was 42 times the cosine of 18. Type it in. Make sure you get 39.9 as your approximate solution. What does 39.9 represent? X, yeah, which is the side length of this triangle, okay? So any questions on that so far? This is using the trig ratios to find the length of the missing side of a right triangle. Okay, when you're asked to solve a right triangle, we're going to do one example of this. I have, I don't know if we'll do the worksheet. I'll probably just give you an example or two. I don't know if we'll do the whole worksheet. But solving a right triangle means figuring out all sides and angles. And you have lots of different methods of doing that. You have the Pythagorean theorem, special right triangles, and now trig ratios. Okay? So when I ask you to solve a right triangle, I'm asking you to find all three angles and all three sides. Okay? And you can do that by any method you want. Inverse trig functions. Okay, we've talked about finding the side lengths of right triangles. What about the angles? This is where the inverse trig functions come in. They are used to find angles when sides are known. And if you look at your calculator, the inverse trig functions are right above the trig functions. If you look at sine, look at your sine button on your calculator. Right above the sine button is the inverse sine button. You'll see a sine to the -1. Right above the cosine is the inverse cosine, and right above tangent is inverse tangent. Okay, so we're going to set up an equation and solve it for the angles in that case. So let me show you how to do this on your calculator. First of all, it says solve for angle to the 10th. So we're given tangent of A equals 7 over 10. So this time I'm asked to solve for A, the angle. So if you're asked to solve for the angle, here's how you do it. You type in inverse tangent of that ratio. It looks just like this. You might want to write it down. Find A. A is equal to inverse tangent of 7 over 10. And you should put the 7 over 10 in parentheses just to be safe. Okay, so on our calculators, I'll show you how it works. Just type in, okay, for my calculator, I get the second function to access the blue inverse sign above that button. Okay. 7 divided by 10. The inverse sign is just like, well, it's the inverse operation of sine, just like square root is the inverse operation of squaring. Okay? That's why on your x squared button on your calculator, guess what's right above it? No, on your square root, on the x squared button, what's above the x squared? No, not above the x squared. It's square root. Because square root is the opposite of. No. I mean, immediately above it. Oh, yours is. Most calculators is. But immediately above it, if you hit the shift function, usually they have the inverse above it. Except on just the theory. That's great. Second shift. Right. Oh. Yours is set up a little different. Yeah. Unless you have a TI 30, it's not like that. But when it comes to sine, cosine, and tangent, their inverses are right above them. Okay, you hit the second and then that. So if I hit enter, I just got 44.4. What does that represent? Side length, angle, what were you looking at here? Let's go back to this. It says solve for the angle. So when I type it in, I just got, looks different. Oh, I did sine, that's why. Sorry, let's go back and try that again. How about inverse tangent? So try inverse tangent of 7 divided by 10. And you should get about 35 degrees. Did you get that? I did inverse sine, sorry. The inverse tangent of 7 over 10 is 35 degrees. Think you guys could do the next two on your calculators for me? Can you find angle B? What are you going to have to type into your calculator? Yeah. So you're going to go to your calculator. We can do one more together here. Second sign, and then I'm going to put in 0.9. Okay, it's not a fraction. It's like they already reduced the or changed it to a decimal for you. So you should get about 64 degrees. Okay. So going back over here. Get 64.2 degrees. Can you find angle C in the next one? What'd you get for angle C? 79.5. Yeah, should have 79.5. Let's see if you can do angle D. Find angle D on your calculator. And hit second. Oh, here's a little different. Yep. Hit second. Scroll down. Anybody else need help? Should get 64.6. Anybody need help finding inverse sine, cosine, tangent? What do we use the inverse functions for? Finding angles. And then what do we use the original ones for? Without the inverse sides. So it says solve the triangle here. So when I ask you to solve the triangle, what am I asking you to do? Figure out all the angles and all the sides. So we'll do one together, and I'll have you try the other one, and if we have time, we'll try some more of them. I think I'm going to wait on the example. This actually shouldn't be here. This comes in the next lesson. That's the next lesson. Applications of this. So solve the triangle. Okay, I have a 2 and a 3 here. How could I find the hypotenuse? Pythagorean theorem would be one way, yeah. That's probably the only way at this point because I don't have any angles to them. So we go 2 squared plus 3 squared equals c squared. And 4 plus 9 is 13. So what does c equal? Square root of 13. So I am over halfway there. I have all 3 sides solved for. And I'm over halfway there because the 90 is there. Now, how could I find angle B? Any ideas on how I could use trig ratios to find angle B? Kind of your choice. You could use any of the 3 trig ratios, believe it or not. If I'm standing at angle B, what would the 2 be with relationship to angle B? Opposite. And what would the 3 be? Adjacent. Which one of the 3 trig ratios involves opposite and adjacent? Tangent, TOA. Tangent does. If you look at it's TOA, right? TOA involves opposite and adjacent. So I could set it up as tangent of B equals what over what? 2 over 3, that's right. And then how do I solve that on my calculator? Do you remember? Second tangent to get the inverse tangent, and then in parentheses 2 over 3.
Will you show me how to that online? Because I can't do it.
So you go second tangent. Oh, yours is reverse. So you get it. If you have a TI-30, anybody else have a TI-30?
Yeah.
You do, don't you? Oh, gosh. Let's do it together here. Yours goes in a different order. Okay, listen carefully. You've got to type in the 2 divided by 3 first. So do it right now. Do 2 divided by 3. 2 divided by 3, and you get a number.
2 divided by 3.
And then hit second, and then the tangent button.
Second
So hit 2 divided by 3.
I got 33.
2 divided by 3. Do that. Hit equals. And then hit second, and then tangent. Tesla, you got to do the same thing. So you get 33.7. So Do 2 divided by 3 first. Yeah, that's correct, yes. This angle is about 33, what was it, 33.6 degrees?
Yeah, 33.69.
So if B is 33.6 degrees and C is 90 degrees, how could you find angle A now? Yeah, add them together, subtract the 180. Yeah, you get to stuff that was true last semester is still true this semester. The 3 angles in a triangle add up to 180. So I can do, actually take the 90 out. Just do 90 minus 33.6. What's 90 minus 33.6? 56.4, that's right. And now you have solved all the sides and for all the sides and angles in a right triangle. So if you could do this, you can do anything I'm going to give you in the homework. Because most of your homework is just find the side or find the angle, and then towards the end you'll have some that are find. They'll say solve the right triangle. Are we clear on what I'm asking for when I say solve the right triangle? That didn't sound very convincing. You only do second tangent if you're solving for the angle, or second cosine. As a matter of fact, hey guys, before I have you try this one, could I have used cosine on this to get my angle B? Okay, what would the ratio be? It would be cosine of B equals what over what? Cosine is not opposite, it's adjacent over hypotenuse. So cosine of B would be 3 over square root of 13, and I do the same process. And I get the same angle, okay? Try this one. Go ahead and try this one. You need to write down the homework. I won't see you again until Tuesday. I would recommend you do the homework tonight while it's fresh. I would on this one, guys, I would find the angle first. Look at how easy it would be to find just this angle here first, right? So find the angle here first, angle G. Quick subtraction problem, you got it. Yeah. What'd you guys get for G? Yeah, you're supposed to be doing this one right now. This should be 55, that's right. 65. Oh, 65, yeah, that would be correct. So 65. Okay, how could I find H now? I want to involve 13 in it, and H. So if I'm standing at angle G, which of the 3 trig ratios involves the adjacent H and the hypotenuse 13? Cosine, that's right. So cosine of 65 degrees equals H over 13. We solve that for H. Maybe a couple more minutes here. X over 1. 1 times H is H. 13 times cosine is 65 degrees. What's 13 times cosine of 65? $5.4. Okay, now you have choices for G. What are your 2 choices? Solving. Okay. Well, it's going to be close to 12, yeah, because it's close to 13, 5, 12. 5, 12, 13. You could use Pythagorean theorem to get G, or If I'm staying at the 65-degree angle, what is G? 13 times cosine of 65.
It's the opposite side.
13 and then cosine 65. So yeah, it's sine of 65 equals opposite over hypotenuse.
Sitting himself for that one. We're just not typing the
Would the following students report to the attendance office of Garrett Matthews? All So, Hamilton, Garrett Matthews, please report to the attendance office.